Okay, welcome to practical number 4, diodes. Uh, so all these practicals are very small practicals, huh? But my objective is to give you some practical knowledge of the things that you have already learned. So especially diodes again, you have learned the theories, applications, and so on. So we are going to look at some practical aspects of diodes. So, a diode is a two-terminal device, like resistor, light emitting diodes, two-terminal device, anode and cathode. There are various types of packages available. The most common types are there are three main common physical views or three common packages. Here you can see this black color diode with silver ring or silver band close to the cathode side, or there will be a glass type one, as well as there is a metallic one, right? So I have given all these three types with you. I think I have only given two types. Yeah, you can see this kind of one. And you can see this type also. This is the glass package one. This is called typically rectified diode. So these are the two types of diodes I have given. Again, back to the right. So first we will fill these blanks. So diode is we call solid state. Diode is a solid state device because before using diodes, as I mentioned earlier, I have mentioned about vacuum tubes during the computer science lecture, because one of the major device was vacuum tubes vacuum tubes, right? So before the vacuum tube, so vacuum tube is it's a vacuum and some sort of gas state is used. Therefore, compared to the previous technology use gas or vacuum, this is better. Solid is easy to handle. That's why we want to highlight this. Diode is a solid state, two-terminal semiconductor device. Okay, semiconductor device. Diode is used for switching. You know that transistor is used for both switching and amplification, but diodes are only used for switching applications. Diode is used for switching function. Diode is an electronic, we call valve. In your bicycle, when you are applying air pressure, there's a valve. Usually valve is used to control the direction of the flow, airflow. When we have a tube, okay, bicycle tube, so when we set the outside temperature to higher value than the inner pressure, it is possible to flow air into the tube. But even though inside pressure is very high compared to the outer pressure, there will be no any air coming out. That's the main idea behind valve. Basically, in our blood circulation system, you have heard about valves. So in the case of diode, as you know, when the anode potential is higher than the cathode potential, there will be a current flow in the direction of the arrowhead. So this arrowhead says this direction is possible. it is possible to flow current in this direction. But the opposite direction, stop. You can't flow current. Right? So that's it. That's how shape is related with the function. One direction is possible, other direction is impossible. Right? So this is 1N4148 diode. It is also available with your package. And also I have put 1N4000 diode. Okay, let's move into the diode characteristic. Diode characteristic. You have already learned these characteristics. Normally, when it is positive, when it is forward bias, we call when the anode port voltage is greater than cathode voltage, we call that direction. When you increase voltage after specific voltage, we call barrier voltage or forward voltage, barrier or forward voltage. The diode will conduct significantly. Diode will conduct the current significantly, right? Maintaining this potential difference. But when we set the potential difference in reverse manner, even though potential difference is high, current is approximately zero. Okay, but there will be small current. This current is called leakage current, but it is negligible, right? But there is a very large value we call breakdown voltage. If you increase to very large value, for example, 100 or 500 volt, then there will be a failure in your valve. Then it is possible to flow the current in other direction, right? So that's the basic principle. So depending on the material, these values are different. Sometimes we know that when it is silicon diode, the VF is 0.7 volt. For a germanium diode, this value is 0.2 volt. Right. Here is a comparison between two types of diodes that I have provided. All of you. This black color diode is there's a black color one. Okay. This black color one is called 1N4000. 1N4007. එක ගහලා තියෙන 1N4007 කියලා. Easily identify 1N4007. කොට එහෙම කරලා යනකොට අහු වෙනෝනේ. I have given three glass type diodes. Okay. Two of them are 1N4148. 1N4148. There will be another one which is a Zener diode. So usually in terms of physical appearance, both are same. You can't identify what is the. If you closely look at, you can see 1N. ගහලා තියෙන 1N. This is 3.9 volt Zener diode. Okay. අනිත් පැත්තට ගන්න මේකේ ගහලා තියෙන්නේ 3V9. You see? Yeah. This is 3V9. 3V9 means 3.9 volt. So this is a Zener diode. You see this one? This one. This is also a Zener diode. I have set this camera to autofocus. සමහරලාට ඔයාලට මේක ලේසියෙන් බලා ගන්න පුළුවන් නේ. මම දෙකක් එකට දීලා තියෙනවා නම් මේක 1N48 එක. see 4148. This is 4148. 414. Okay, you can see something like this. 1N, 1N, 4148, something like that. So take a photo and enlarge it, zoom color. Then you can find if it is difficult to find the right. So if you know that basic diode circuits, usually this is the typical page number 9. You can find the typical circuit that we use. This is the forward bias condition, right? When the anode voltage is higher than the cathode voltage, we have forward bias condition. This is the reverse bias condition. So you don't have a multimeter, no? Therefore, I will use my multimeter and set the circuit and measure the values and show you. If you have an Arduino board, later when you are doing Arduino practicals, you can create a multimeter or voltmeter by using your Arduino Uno board and the computer. Then at that time, definitely you can measure all these voltages, right? At the moment, I will simply set up the circuit and show you how to measure and show you the values, right? Okay, right. I think it's better to make this, better to set and show you. Therefore, I will post the recording and set up. Then, right, look at, so here I have set this. The thing is that if you did not use your 9-volt battery for longer time, okay, if you did not use this battery for longer time, definitely you have to buy a new battery. Because all the batteries are very cheap batteries, they will not run for longer time. There may be some expire date in the back. We cannot see any deaders. $22 cinema sector. So here I have used 1N 4007 diode. Okay, anode positive terminal is connected to the anode, and the negative terminal is connected to the resistor here. Then I'm going to use the multimeter. Now I have set to 10-volt scale, right? 10-volt again. First, I will measure the circuit voltage, total supply voltage. You see, as it is a 9-volt battery, you can see exactly 9 volt. Exactly 9 volt. Okay. Now I am going to measure the diode voltage. Now you can see that diode voltage is less than 1 volt. See? You have to refer the 10-volt scale. 10-volt scale like okay. It's 0.7 volt now. Okay. So if you set it into reverse bias mode, there will be no any current flow. Therefore, entire supply voltage will be across. Now the supply voltage you see 9 volt. Supply voltage is 9 volt. If you measure the potential difference across the diode, now the have changed the polarity. Yeah? Positive terminal is kept to the cathode. That's why you can see it as 9 volt plus 9 volt. There is no any current flow. As it is no current flow, you can see that no any potential difference across this resistor. No any potential difference across this resistor. So that is the simple forward bias, reverse bias circuit. Okay, we measure these voltages. Voltage across the diode and the voltage across the resistor. Here I use a resistor 9 volt, 0.7 volt. rest is here, right? When it is reverse bias, no any current flow means no any potential difference across the uh, LED. The entire supply voltage is across the diode. Okay, right. I want to discuss the difference between 1N4007, the black color one, and 1N4148, the glass type one. The difference between these two, right? Uh, Normally, in most of the practical applications, we can use any of these diodes. Don't worry. Okay, but there are some considerable differences. You see that forward voltage or barrier voltage is 1 volt කියලා තමයි කියන්නේ 0.7 උනා. I think 0.7 උනා පැදී පොඩ්ඩක් වැඩි නේ typical value you can consider it as 1 volt. Okay. 4007 can be used for 1 ampere of maximum forward current. You see, when it is forward bias, there's a maximum current that you can send. You can't send 5 ampere, 10 ampere. So 4001 having 1 ampere current. Right? There are some other diodes you can send more than one. But 1N4148 having 150 milliampere of maximum current, you cannot send too much of current. This is because this 41 glass type one is sensitive, right? Sensitive. So especially here, in 4008, 4007, reverse breakdown voltage, this VBR reverse breakdown voltage is very high. Here 100 volt, but here 1000 volt, 100 volt. කියන්නේ reverse bias volt 100ක් විතර වෙනකම් මේකට දෙන්න පුළුවන්. ඒක මම නම් හිතන්නේ මේ හරිම values නෙමෙයි. නිකම් මේ අර roughly දාලා තියෙන්නේ. මේකට 100ක් වගේ තමයි දෙන්න පුළුවන්. 200ක් විතර දුන්නොත් මේක pitch වෙනවා. It will be burn. You cannot reverse the process. මේක එහෙම එන්නේ මේක එක තැනකට ඇවිල්ලා මේ හරිය අතහැරියම ආයෙ මෙහෙම යන්න පුළුවන්. මේ reversible. If you pass this point, it is irreversible. You cannot reverse irreversible. So the other important point that I want to mention is the reverse recovery time. What is it? Reverse recovery time means, you know, when the diode is in reverse bias mode, reverse recovery means reverse bias mode, right? You know, there's a layer, depletion layer is a PN junction. The junction having a special layer called depletion layer. So when we increase the reverse bias voltage, what happens is depletion layer will increase. When we apply the voltage in other direction, gradually depletion layer will vanish. Then we start to flow current. Now in reverse bias mode, the depletion layer will increase, right? So once the depletion layer which is increased, it takes 30 microseconds. It takes 30 microseconds to recover, to come to original state. In the case of 4148, it is very faster than 4007, so which is used just 4 nanoseconds. You see, okay, nano micro, right? Therefore, if you want to forward bias, reverse bias very fast manner, that means if you have to deal with nanoseconds, then better to use the expensive 4148. Even though it is expensive, you know, the current is limited, maximum reverse voltage is also limited. But here, normally we in rectification, rectify කරනවා කියලා කියන්නේ සිංහල නමක් AC ඒව DC කරනකොට අපි කරන්නේ rectification කියලා කියන්නේ I can't remember the single term at the moment. රුජු කරනකොට rectification වලදී අපිට සාමාන්‍ය 50 hertz නේ 50 hertz you have to deal with 50 hertz. So 50 hertz means 20 milliseconds is the time period. So the rectification we have to deal with milliseconds. Therefore 30 microsecond recovery time is enough. Therefore most of the rectification applications are where rectifiers හදනකොට ඒ කියන්නේ අපි AC DC කරන circuit වලදී ගොඩක් වෙලාවට ඔය black color 4007 එක තමයි use වෙන්නේ. but switching වලදී let's say on off situation වලදී if you want to operate more fast, then you have to use the switching diode 4148. There's another application of diode called freewheeling. Now we are going to discuss it. Next practical we are going to discuss. Today we are going to discuss the freewheeling. Then I will show you what is it. In freewheeling, also we have to deal with high speeds and so on. Therefore, you can use the 1N4148. 41 48 use කරන්න පුළුවන්. මේක 4007. Okay, so those are the main difference between 4148 and right. So as a application of diodes, we cannot do rectification because you don't have AC supply, low voltage AC supply in your home. You can find 230 volt where it can be cause damages. There can be electric shock for you, current or influence. Therefore, we cannot deal with AC. If you have a transformer, we can reduce and use, but at the moment we don't have. Therefore, I'm going to explain this circuit. You see, this is a simple transistor, BC547 transistor, let's say. For from supply voltage to collector, I have put a motor, DC motor. Okay, DC motor. Then the motor can be on and off by providing some voltage to the base terminal, right? So because we are going to use this transistor as a switch. And the thing is that if you remember BC547, normally in BC547 we can only take a microamp. This is 577 557 557 එක micro නේ එදා කලින් දවසකට අපි කතා කරා මේ characteristic curve of BC547, you see only microamperes. Summoning the DC motors cut for the motors consume more than micro, they will consume milliamp. Therefore, it is not sufficient to use BC547. If you want, you can use BC547 and test this circuit. Okay, you can test this circuit, but sometimes motor will not rotate. Motor will not rotate because current is not enough. The other thing is that the transistor will be reached to a very high temperature due to higher current flow. Now, සාපේක්ෂව current එක වැඩි වෙන then the transistor will immediately burn. Therefore, better to use BC547. Okay, BC547. BC547. This is the pin configuration. It is also NPN transistor, suitable for high currents. When you take the transistor from the flat side, leftmost element is the emitter, middle one is collector, base, right? Flat පැත්තෙන් බැලුවම emitter, collector, base කියලා තමයි තියෙන්නේ. Emitter, collector, base. So in D400 transistor, size එකනොත් අනිත් එකට වැඩි චුට්ටක් ලොකුයි. D400, you can see it is possible to flow milliamperes rather than microampere in the case of the previous one, right? There's another thing to be explained. That is for motor is used to convert electrical energy into mechanical energy. Motor is used to convert electrical energy to mechanical energy, right? And the generator or dynamo is used for opposite mechanism. Mechanical energy is converted into electrical energy, right? Therefore, once we turn on a motor, it will rotate. No, even we stop the current flow, right? Let's say I have a motor here. When we find this kind of motor, when we rotate this, right, due to the angular momentum, it will rotate several turns. Therefore, at that time, your motor will work as what? Work as a generator. Therefore, we need to pay attention for that. We need to consider it. We need to pay our attention. Right? Let's say you have turned your motor on by providing some supply here. When you turn off, still motor will rotate. The motor will rotate means still there will be a current flow. Still there will be a current flow through the motor. still there will be a current flow through the motor in the same direction. In the same direction. So that current may cause some damage to your transistor and other circuits. Therefore, what we are going to do is we are going to use a diode. We are going to use a diode like this, and the diode will flow through this. Current will flow through this diode. It's like a wheel, no? It's free to rotate. Therefore, this is called freewheeling diode. But in the normal operation, the current flow is in downward direction. When the transistor is turned on, current flow is in downward direction. At that time, the upside, this plus position voltage is higher than this voltage. Therefore, in that case, it is not possible to flow current in downward direction. But once the turn is off, still motor is rotating. Then motor is act as a battery, no? Then that one or that current in the same direction will be freely rotate through this diode. Therefore, this diode is called freewheeling diode. Freewheeling diode freewheeling diode. Therefore, if you want to control, the motor, operation of a motor by small voltage or current, then you have to use a transistor because motor current is high. Then, in order to avoid the there's a name for that, we call back EMF, back electromotive force. When once we turn off, we need to use this kind of freewheeling diode. So today we are going to construct this circuit. Okay, today we are going to construct this circuit. So we have to use what? We have to use the motor too. So this is my motor. Initially, you can provide some direct power 9 volt and see whether it is rotating, right? It's rotating. I will turn it in other direction, and it will rotate in opposite direction. I just paste a sticker here to see that it is rotating. So directly we can turn this on and off, no? But now I am going to control this by using a switch. So this is the D400 transistor, right? D400. When you look at it from the flat side, this is the emitter. If you look at it from the flat side, flat pattern balloon, this is flat side, right? Flat pattern balloon. Emitter, collector, this. So now I am going to fix it somewhere here, right? According to my configuration, the topmost element is the collector now. The topmost element is the top. First terminal is the base. Okay. Then the next term, next one is the collector. Bottom one is the emitter. So I need to provide my negative supply to emitter. Negative supply to emitter. The positive terminal here, right? And this is my motor terminal, yellow color one and brown color terminals. So I will, the middle terminal is the collector. A motor is set, right? And I have to use 1 kilo ohms or 220 ohms resistor to connect the positive supply to base terminal. So immediately you can see that motor is rotating, right? Immediately you can. Okay, motor is rotating, but this is not a good way. No? We have to use the freewheeling diode to freewheeling diode. Because make a when the motor is running with a configurable load and so on, even though it can be automatically rotate, there can be certain cases. Therefore, we must use the freewheeling diode. එතකොට උඩටනේ කරන්ට් එක යන්න ඕන විදිහට හදන්න ඕනේ ඒක. collector එක පැත්තට current එක යනනේ හදන්න ඕනේ. So I use the freewheeling diode here. Okay, it's my freewheeling diode. With the villain. So I will use a push button. I have push button. There is a push button. Yeah. Then push button එක දාන positive terminal එක පැත්තට. Push button. Then 1K resistor. Brown, black, red 1K resistor is connected to the one terminal of the switch. Other side is connected to the positive side. Can you understand? Positive side එක නෙවෙයිද තියෙන්නේ. ඒකට අපි switch එක හරහා තමයි resistor එක connect කරලා තියෙන්නේ. Then when I turn this, push this, okay. So normally we don't have to construct this circuit. We don't have to use a D400 transistor. Okay, or this freewheeling, all these things. There's a separate module. There's a separate module called motor driver. So what we construct is a motor driver circuit. No? That I will explain when you are doing Arduino practical. You can separately buy this, right? In that one, we are using 4 such switches. One like this. By using 4 such switches, it is possible to control the direction of the current flow through the motor. That means motor can be rotated forward by as well. Motor can be rotated into one side as well as other side, right? Arduino වලදී අපි ඒක use කරනවා. Then you will realize this. Here I am going to use a capacitor. Low capacitor that way. I will keep this capacitor in between the emitter and the switch එක පැත්තට. This is a delay time. That means when I push this, it will rotate for certain time and stop. I here use 1000 microfarad transistor capacitor, but you don't have that one. You have 100 microfarad. No? Therefore, it will not last for this much of time. කලින් එක check වෙලා යනවා. Okay, so this is the circuit that I want to introduce. Anything else? Practical enough, right? We use a D400 transistor. It can be used for higher currents rather than the BC54. They have used BC547. It's an NPN transistor, D400 NPN transistor. We use switch. We use diode as a switch. Diode as a freewheeling. It's called freewheeling application. It's an application of diode. Okay, the next practical we are going to discuss the Zener diodes. Okay, bye.